Good morning, this is Mrs. Boots, and this is our part 2 of our trig function graphs. So we have our cosecant. Remember, cosecant was 1 over our sine value. Okay, so all we did was flip our sine value. So everywhere my cosecant was equal, or my sine is equal to 0, I would be dividing by 0. That's going to give me a vertical asymptote. So I'm going to compare right up here with this graph, and everywhere my sine is 0, which is at 0, pi, and 2 pi, I'm going to have vertical asymptotes. So at 0, pi, and 2 pi, we have vertical asymptotes. Now remember, it's like we cut the wave and we split it. So at pi over 2, my value is still 1, and at 3 pi over 2, my value is still negative 1. But we cut the wave right down the x-axis, and we flip that wave up and out of the way. So this would be my cosecant wave. So my cosecant, the domain is going from negative infinity to infinity, but just like the tangent, we're being interrupted by these asymptotes. And so my x's cannot equal, or my theta cannot equal, n times pi. So a whole number times pi. So 1 pi, 2 pi, 3 pi, 4 pi. Every single one of those is going to have an asymptote. My range is rather peculiar. It's similar to our rational functions where there's a gap in the middle. So I'm going from negative infinity up to negative 1. There is a bracket at negative 1 because we're right on the curve. Then we're going to have a U shape, and we're going to go from positive 1 to infinity. Okay, so we got that gap in the middle right here where the curve does not exist. Our midline is still 0. So notice the middle of my graph is 0. The amplitude, it doesn't really have an amplitude because it keeps going. But my period is just going to be pi. Now, how did I get that? So notice, I'm sorry, that's 2 pi. Notice the pattern's going to repeat after 2 pi. So I start with 2 pi minus pi, just like with the sine wave, because it's 1 over sine. So it's going to be 2 pi. All right. So now let's do our secant. How did we get our secant? Our secant was our cosine wave flipped. So my cosine equals to 0 at pi over 2 and at 3 pi over 2. So 1 over 0 can't do that. So these are both vertical asymptotes. And now we would have our value of 1, negative 1, and positive 1. Because 1 divided by 1, we flip it, we still get the 1. Okay, so my secant looks very similar to my cosine. All we did was cut the wave in half, flip the top part up, flip the bottom part down. The domain is going to look almost like our beautiful cosecant, only this time x is not equal to, n times pi over 2. So any value where I have pi over 2, so 1 pi over 2, 3 pi over 2, 5 pi over 2, all of those. Okay, my range is identical. Okay, so I'm going from negative infinity to negative 1. I have a square bracket. Then I do a U shape because there's a gap. And then I'm going to start at positive 1 and go to positive infinity. The middle of this wave formation is still 0, and there's no amplitude because it's going to infinities in there. We don't have an amplitude. My period is 2 pi, just like it was for cosine. All we did was cut the wave apart. All right? So now let's look at cotangent. When I take my tangent and flip it, that means everywhere it was 0, my cotangent is now undefined. So that would be a 0 and at pi, and then it would keep going for 2 pi. All right? Everywhere it was undefined, it's now 0. And then our cotangent is simply our tangent flip. So where it was positive, it's now negative. It's really cool. It kind of looks like a cubic. Okay, so my tangent looks very similar to the cubic. Get some little curves in there. All right. So my domain is from negative infinity to infinity. Only x cannot equal what? All the pi's. So n times pi. My range is just negative infinity, positive infinity, because I have the arrows that's both going to the top and to the bottom. Our midline is at 0. Notice I didn't even put amplitude in here. And the period, notice it repeats. So I've got one wave right here between 0 and pi, and then it repeats. So my period is just pi. And those would be our 3 other trig function graphs. Thank you. You guys are awesome.